Alright, welcome to the channel. We have a interesting little problem with a ceiling fan in the bedroom. And what will happen is it has two switches, like most of them out there. So we got one for the light that's on the fan, and then this one over here is for the fan motor itself. And what will happen is the lights will continue to work, but after probably 10 or 15 minutes, then the fan motor will just stop. I'm suspecting a bad switch for the fan motor. But we're going to check it out and we're going to see if we can catch it in the act. Now just so you can see that the light's on and you can see that the fan works. Okay? So now what we're going to do, first thing I want to do is we're going to go to the panel and we're going to find a breaker to turn off the power to these lights and to the fan motor. Now to save us a little bit of time, I've already found out which breaker it is. I've marked it with tape and I'm just going to turn it off. As you can see, I still have the switches in their own position, and if we look up at the fan and also at the lights, we now know that that is on one circuit. That's where most of these fan motors are going to be wired with one circuit, but we want to verify that. Now as I mentioned, the lights will continue to stay on. The fan motor will go off after about 10 to 15 minutes of running. So we have verified that the breaker is good because the lights are on. So now what we're going to do is I'm going to go ahead and I'm going to take off this here switch plate cover. So I got the 4 screws out, so let's remove this switch plate cover. I mentioned earlier the one on the left is for the fan motor. So I'm going to be taking these 2 screws out and we're going to pull this here switch out. Alright, so we got it pulled out now. A little bit more access to the wires in the back. I'm just going to go ahead and I'm going to remove this switch also. Now as you can see, I have my voltmeter leads across that switch for the fan motor. And you can see we have the voltmeter and it's set for volts AC. So now I'm going to go in and we're going to turn the power on at the breaker. Alright, you can see that the fan motor's running, the lights are on. So let's monitor this voltage on the switch. Alright, right now we got 19.1 millivolts, which is very good. So I'm not quite sure how long it'll take, maybe 10-15 minutes, but I'm going to sit here and monitor it, and when it comes by, if it does act up, you know, with the fan motor stopping, then I'll catch you back in the next shot. Alright, after 8 minutes, then the fan motor has turned off and the lights are still on. And what do we notice with our switch in the closed position? We notice that we got 2.4 millivolts. So it is not the switch. Now let me show you what will happen if the switch was to open. I'm just going to turn the switch to the off position. Now if you notice, we got 121 volts. So this switch is good, going back to the closed position. So we need a little more detective work here. Alright, so we know it's not the switch. So now we're going to put our focus up here on the fan motor itself. Alright, so what I'm going to do now is I'm going to remove this here light fixture and drop it down. And there's 3 screws, 3 Phillips screws around here. So there's one of them I've already taken out, and then there's 2 more. So once I get those out, I'll catch you back in the next shot. Now I've got the breaker turned off. So what I'm going to do is, well, first of all, I can see that there are 2 capacitor blocks in here. One is over here and then one's on this side. So what I want to do is I'm just going to take all this stuff and I'm just going to drop it down. I'm going to take the reverse switch out, drop it down so I can just kind of trace these wires out a little bit, get a little more access to these capacitors, and then we'll go from there. And also I'm going to take this 3-speed switch out. So basically we can unhook this chain like so, and then we'll take this here, screw it off. And then this here will drop right out and come on down. Alright, you can see that I have everything down. Now I want to stress that when you're working on capacitors, if you're going to be taking those out, the capacitors will hold a charge. And this is even with the power turned off. So before you start taking the connections out for the capacitor, you want to be sure to jump the terminals across the capacitor to discharge them if there's any power on them. So you take like a little jumper wire, and once I took the 3-speed selector switch out, because some of the capacitors are going to be going into that switch, you can take your terminals, your jumper wire, put it there, say to one side of the capacitor, touch the other terminal to be sure it's discharged. And I'll go over that a little bit more a little bit later in the video to show you which terminals to touch, you know, as far as on the capacitor. Alright, these are all the components that's inside that junction box. You can see we have 2 capacitors. This is one capacitor block, but it actually has 2 capacitors inside. And we're going to go over each one of these components in a little more detail. Then we have another capacitor. This is just one. Then we have our reversing switch. And then we have our 3-speed selector switch. And we're going to start with this one right here. Alright. Now, these units, what they do is this, the wire will push into the terminal, then it kind of locks it. If you look at receptacles, you know, when you're backstabbing them, so you push it in and then that locks in. So to release these wires, and I left one in just to show you, and I've already got the other 3 out. You'll take a scribe, got a real thin tip on it, and you just want to push down beside the wire. And then while you're pushing it down, and it can be a little tricky trying to get these things to release. Now, what I did is I went just right up above the wire and I pushed it in, and while it's in, then you could just pull it out. Now this is a 4-position switch. It's kind of like a rotary switch, where the L is going to be the common terminal to one or more of these other terminals, which is 2, 1, and 3. And I took that wire that I removed and I just put it into the L terminal, and then I got an alligator clip. And what we're going to do is we're going to be checking resistance. Alright, so what we're going to do is we're going to zero out the meter, so I'm going to jump the leads together. Then I'm going to press the REL, that'll zero out the meter. And I'm just going to leave the beeper off because that's annoying as hell, listen to a beeper. Is. So we'll just look at the meter on each test. So I'm going to click on to the L terminal, and right now it's in the off position. So we should not have any continuity between the L terminal and any one of these other terminals. So if you look right down in there, I'm going to just show you this one. You can see there's a brass insert. This is the spring clip that holds the wire in. So I'm just going to touch that, and as you can see on the meter, it's open. Over here on the next one, it's open. Going over to the terminal 3, it's going to be open. Now, before we go to the next position, which should be high, I'm going to go ahead and do that. We're in the high position. There are different styles of these selector switches. In other words, they're going to be a different switch configuration between the L terminal, which is always going to be common no matter what style you have, between these other terminals. Now, in my particular case, this I believe is the most common, but there is another configuration out there where L in the high position, 1 is high, and then 1 is high, 2 is medium, 3 is low. So it will connect L to 1 in high, L to 2 in medium, and L to 3 in low. But this here style is going to be different, as you'll see. So in the high position, we're going to connect L to 1, which is right over here. So we should get a reading. And you can see it went right on down to 0. Now keep in mind now, resistance checking is not the best check. I don't like to do that, but if we have some kind of issue, hopefully it'll show up here. Alright, so let's go over to terminal 2. That should be open. And it is. And then finally to terminal 3. And it is. Alright. Now let's go to the medium speed. Now on the medium speed, it's going to connect the L terminal to terminals 2 and to terminal 3, but not to 1. So let's check terminal 2. You can see that we have pretty close right on to 0. Now let's go over to terminal 3. Now right off the bat, I don't know if you saw it, but you see it's jumping all over the place. Ooh, no. Alright, so we can call that terminal bad. Alright, and I've got good contact on that brass terminal in there. Alright, so we know we got one terminal bad on the medium speed. And finally, on terminal 1, we should not have anything. And we don't. Now let's go to the low speed. Now on the low speed, we should be connecting L to terminal 3, but not to 2 and not to 1. So let's check 3 to see if we got anything there now. And you can see, I see the little jumping going around. Yep. And I'm holding the meter lead on that brass terminal and I'm holding it steady. Alright, so we should not have anything on terminal, this is terminal 2. Nothing. And I'm sorry, that was terminal 1. Yeah, we had it on 3. We should not have nothing on 1. Nothing. And on terminal 2, nothing. Okay? And then we'll go back to the off position, which of course there should be no continuity on any of them as we already checked. So that takes care of this. So that's one item that we're going to replace. Now since we were talking about different styles of these selector switches, or categories as they're sometimes called, here's a brochure I found on the internet, and I'll put a link to in the description. So this is category 1 or style 1, and then they list the other ones. Here's category 2. This is the one that I have, which we already covered. Then we have a category 3. We got a category 4. This one right here is for 4-speed. All the ones that I listed in the video was 3 styles, and that's for a 3-speed fan. Alright, this is talking about the capacitors now, so we're going to be looking at those next. Now, I mentioned earlier in the video that if you're going to be taking the capacitors out, maybe you have a bad capacitor and you're going to take it out. Now, even with the power off, you can still have a charge on these capacitors. Now, for example, I'll give you an example of how to do this. This particular capacitor was connected into one of the terminals here on the, actually it was the red wire, was connected into the selector switch. The other one right here went to the neutral wire, which had a crimp on it, as you saw earlier in the video. So what you have to do is you want to take your jumper, probably something a little bit longer than this. You want to go up inside the butt connector, touch there, and then wherever this other wire is for your capacitor, you want to be shorting these out, right? So you're basically going to be doing this. You're going to be touching these 2 wires to short. Okay. Now when you get to another capacitor, say like this one, you can notice that the 2 capacitors are tied together on one side. So you're going to be looking at this brown wire because that's common to both of the capacitors. So wherever this wire is going, get your jumper wire, get in there and touch that one, and then you want to touch, say, this capacitor for the purple wire. So basically you're taking the brown and the purple, you're shorting them together, and then you want to do the brown to the gray, and you want to short them 2 together. So wherever they go, get up in there, get your little jumper wire, touch them together, make sure they're discharged. Once you do that, then it's safe. Then you could go ahead and take the capacitors out. Okay, now let's look at checking the capacitors. Well, one of the first things you can do is take a look at it visually. See if you see any bulging, any swelling of it, any hot spots. Maybe you might see a circle here. Maybe it's puckered out, overheated. If you see any signs of that, then you know the capacitor is automatically bad. And in this case, it looks pretty darn good, just like it was brand new. Alright, this one over here looks the same. Don't see any hot spots, no burns, no swelling. Everything looks good. But because it looks good does not mean that it's good. You have to check the capacitance of this. So that's what we're going to get ready to do now. Alright, next we're going to check the capacitors. You can already see that I'm on the mode for capacitance. but I have to press the yellow button to get that function. So now we're there. And let me go ahead and put my other meter lead on here, or alligator clip I should say, and I'm just going to click it on, and I'm going to click it on. Now it should be 4.5 microfarads, plus or minus. Looks like plus or minus 5%, I guess it is. 4.5 microfarad, rated at 250 volts, 50-60 hertz. And what do we have? 4.55 microfarads. So this capacitor is good. So we're going to reuse him. Now let's bring in the next capacitor. Now this is two capacitors in one assembly. You can see that we have the brown wire. The brown wire is tying both sides of the plates of the capacitor on one side. There's one capacitor on one side, there's the other capacitor. So let's put our brown lead, get it connected up. And then we're going to go, let's do the purple one first. Purple should be 4 microfarads. And what do we have? We've got 4.17 microfarads, so that is good. Now we're going to go to the gray wire, and that one is going to be 4.5 microfarads. And what do we have? 4.66 microfarads. Okay, so our capacitors are good. Last on the list, we have our reverse switch. The reverse switch is to reverse the current in the run windings of the motor to make the motor go clockwise or anti-clockwise. Now this is a double pole, double throw switch. Now basically what that is, we have two individual switches. One switch is over here and one switch is over here. All right, and we're going to go and we're going to look at how to check this out. Now if you notice in the center, just like on the 3-speed selector switch, we had a common terminal, which was the L, and it was common to the other terminals. In this case, with this switch, the center terminals are common. So this here terminal on this side is common to this wire, and this here common terminal in the center is common to this one and to this one. So let's go ahead and let's hook it up. We're going to grab a common terminal, and at first let's go back to a meter. So we were already on checking capacitors, so let's get out of that. Okay, let's go back and we'll re-zero our leads. Hit the REL, 0. I'm going to leave the beeper off since it is knowing. You can leave it on yours if you want to. So I'm connecting to one of the common terminals. And if you look at this here switch, you see how it's down at the bottom? So this here is going to be made. So it should be closed. The other one up here, at the same time, it should be open. So let's see what we got. All right, you see we got 3.4, 3.5 ohms. That is a little bit high. We should be pretty close to 0 or maybe 0.1. In a case like this also, what you want to do is with the handle of the switch, you want to kind of move it a little bit. And I'm jumping. Okay, so we already know that that contact is bad. All right, let's go down, and what we're going to do is we're going to switch up to this other terminal on the same side, and it should be open. As you see, it is open. Now if I flip the switch, it's going to close. So I'm going to flip the switch. See, it's 0.9, still a little bit high. Should be closer to 0. Again, move it. Move the switch here. Yep. Okay, so we're going to call that one bad. Now if I go over to the other side, and I'll just put the switch back where it was, you notice that what I'm doing is I'm looking at the position of the switch, and I can say right now in the down position, you see how these two, they should be closed. At the same time, if I go to the common terminal over here in the yellow, it should be closed. So if I go over there, going to get on the common terminal, which is the center one, and then get on this one down here at the bottom, and you can see that it is closed. And you can see it's kind of bouncing around. So we know that one is bad. Again, just like the other side, if I was to go up to here, then it should be open. And it is. And if I throw the switch, then it should reverse and it should close. And it does. Move it around a little bit. Bounce it around a little bit. Not as bad as the other side though. Now if I go and take and move this down to the bottom, then it should be open. And it is. And again, if I throw the switch, then it should go back to being closed. You can see that resistance on that one is pretty high. So that's going to be a bad switch. So we are going to get a reversing switch and a 3-speed selector switch, and we're going to reuse the capacitors. Alright, so this is our old reverse switch. This is the new one. Now you may have noticed that I've got wire numbers on every one of the components. And the reason I do that is before I take anything apart, I'll put wire numbers on everything. And the reason for that is if you'll take a look, these color codes on this here are different than this one here. Alright, so if we look at the white, that one is okay. Now you see we got a yellow, that's okay. Here we have an orange, but now it's turned to red. Red on this side is orange on this side. And then over here, this was the brown wire, but now it's a gray wire. So I'll put the wire numbers here to match up to that. So when I go to wire it up, I know it's going to be okay. And what I use is just the Brady marker here. This can be used, you know, you can set it up for a wire marker mode. And so this is what I this is what I used when I was doing some control wiring, industrial control wiring. Okay, now we're going to show you what a new switch should check like. You remember the old switch, the numbers were flickering all over the place. I mentioned this was a double pole, double throw switch. This will be one switch, this will be the other switch, and you can think of this as two single pole, double throw switches that'll gang together. So, I'm looking at my handle, it's down, so I know this should be closed, and I know this should be closed. So I'm going to go ahead, I'm going to put my meter on there. This case is going to be the red wire and the gray wire. Okay. Now again, go back to your handle, move it around a little bit. And I'm moving it and nothing is happening. Now I'm going to just switch over to the other side, which would be the yellow wire and the white wire, and it should be closed. Again, we got 0 ohms. I'm moving the handle. Nothing happens. Now I'm not going to go through the whole thing to show you about the open and the open. You remember that from the old one, but they all checked good. Okay, we got a brand new selector switch. This is the category 2 or style 2, whichever you prefer. Here's my L terminal. Now right now it's in the off position, so I should not have any continuity between any of these terminals. So that's my L. There's 3. There is 1. And there is 2. And I've got nothing on any of them. I'm going to go to the high position. Find my L, which is right here. Terminal 1 is over here. And you can see we got 0. Yep, 0 ohms. I should not have anything else. Nothing. And nothing. Going to the medium. Going to L. I should have continuity on 2, which I do. And then I'm going to go to 3, which is over here, which I do. And I should not have nothing on 1. And I do not. Finally, we go to low. I should have continuity between L and also on 1. Let me see if I can get the right terminal here. No, I'm sorry. On low it should be L to 3.
Okay.
Yep, L to 3. There we go. Got 0 ohms. Should not be nothing on 3. I'm sorry. Should not be nothing on 1. And it should not be nothing on 2. So, that switch looks good. Okay, so before I took all those wires and disconnected them, I went ahead and I drew up a quick sketch. And from this sketch of the wiring diagram, I turned around and I generated some drawings and I put them in CAD. This is showing all of the modes of operation. In other words, it's in off, high, medium, and low. And from that, this is just a blow up of each one of these modes. And from having these diagrams, we could do a hell of a lot of engineering, electrical engineering videos on it. Just to give an example, we could calculate the inductive and capacitive reactance. We could calculate the phase angles between the voltage and current in the start and run windings. We could also use complex numbers, which is a real and imaginary numbers. We could show how to add, subtract, multiply, and divide those numbers. We could also show how to put these numbers in rectangular and polar format. Of course, then we'd have to talk about trigonometry. We could calculate about the power factor of this here motor circuit. And I mean, just the list, you know, goes on and on. Maybe down the road we might do some videos on that. Now, since this is an electrical troubleshooting video for our ceiling fans, and we're checking all these components, then we ought to mention about the windings for the motors. All right, so we're going to have a run winding, and sometimes you might hear that as a main winding, and the other winding is a start winding. Sometimes you might hear that as a auxiliary winding. Now, in my particular case, and this was red. This was brown, and then this one right here was for me was 72 ohms. This one over here was 87.3 ohms, and the color of the wires was orange and yellow. How can you tell which one is which? The one with the highest resistance is always going to be your start winding. Okay. One other thing you want to do is you want to put your meter leads on one of these here. Of course, all of these wires are disconnected. You want to put your meter leads, you got it on ohms, and you're checking it to ground. You're checking to see if this here motor winding is going to show any kind of resistance. That makes sure that it's not grounded. It should read OL. And of course, you want to do the same thing over here on this side. Now that's going to leave your black wire. That's the incoming power that's coming in. That's your sometimes L1, hot, or 120 volts AC. Then you're going to have your neutral wire, that's white. And then you're going to have another wire that's up in the canopy next to the ceiling. It's just going to be a blue wire, and it's going to come down to that bottom fixture for the fixture. So this one is going to be for the light. So the blue wire, typically what it'll do, you'll tie it right to the black, unless you have a separate switch. In my case, in that case, then what you're going to do is going to go back to a separate switch, and then you're going to get your power like so. This will go back to the panel, and then we have the light. So yeah, so that's pretty much it. Now let's go in there and let's take and put all these parts in this fan, and let's see if we got it fixed. Okay, everything is working fine. It has been running for about 3.5 hours. I have gone through every speed. Everything looks good. I've gone through the reverse. I've changed it. And so right now it's in a high speed. Been going there probably about 3.5 hours. So everything is looking good. If you notice, there are some slots around the motor housing cover on the bottom, and there's also slots on the tops. That's for the air to circulate to cool the motor windings. You want to be sure to take your vacuum cleaner if there's any dust, dirt, debris. You want to get all that stuff off, top and the bottom. If you don't and it gets too clogged, then what's going to happen is there's going to be a thermal fuse inside that motor windings, and it's going to open up. That fuse is going to open up around 145 degrees Fahrenheit. Once it opens, that's it. It's not going to reset. Then you got to go in there and open the motor housing and everything to replace that thermal fuse. So that's going to wrap this video up. Hopefully you learned something, and we'll see you in the next one.